Once you're ready to do some welding, you got to make sure that you prepare your materials correctly. What I mean by that is when the steels are made at the mill, as the metals are melted down, all the impurities of the metal rise to the surface, and it creates what's called mill scale on the outside of the metal. And we want to remove that when we weld. Any of the impurities that are there, the mill scale, rust, paint, oils, adhesives, stickers, anything that's on the metal has to be removed so that we can get down to the pure metal and create a solid, good weld. As you can see on these pieces of metal, I prepped them. As you can see, this piece of metal here, I removed the mill scale on it. The shiny part of the steel is the pure metal. The gray coating on the outside of all the rest of this metal is called mill scale. That's going to cause a problem when you start welding. Now, there are welding rods that can just bust right through the mill scale and make welds. But in order to get a solid, pure weld, you really need to be welding on the pure steel. So I've prepped this metal for welding. I removed the mill scale, and I ground a groove into it. Here, on the edge. I cut the corner off, basically. What that does is when we put the two pieces of metal together and go to weld them, it creates like a little channel or a V groove that the weld can sit into. That makes sure we're getting real good penetration into the metal, and that we're deep enough with the root of the weld that we're going to make a solid weld all the way across these two pieces. This configuration here, this joint is called a butt weld or a seam weld. When you put these two together and butt them up against each other and then weld them together, it's called a butt weld. We talked about the sander, the belt sander, and the bench grinder, but that would be hard to get the flat surface against either of those and make a nice clean removal of that mill scale. So what I used was the angle grinder. The angle grinder is a great tool. It's versatile. You can do many things with it. There's a lot of different attachments. There's a stone attachment, a sanding disc attachment, which is what's called a flap wheel. It's just layered pieces of sandpaper layered on top of each other around in a circle, and it's pretty thick. It does a good sanding job. The stone cuts much deeper into the metal than the sanding disc will. Flap discs are only meant to clean the surfaces and maybe remove some material. They're not designed to do heavy work like the stones are. Stones will remove a lot more metal a lot quicker, but they leave a rough kind of cut. And then you go over that cut with the flap wheel to clean up the surface. You can also use cutting discs on the angle grinder, and you can cut right through metal. If I put this disc on, I could cut right through this piece of metal with this disc. And then there's wire brush. Wire brush is similar to the sanding disc, where it won't cut into the metal, but it will clean the surface of the metal. This is even less aggressive than the sanding wheel, and is only for cleaning the surface. maybe surface rust or something like that, where the little needles can get down into the grooves. So how do we get these tools onto the machine? So obviously they all have a center hole. Okay, you can see that these two attachments, they screw right on. But these attachments just have holes in the center. To screw them on, you obviously just put on the thread and screw on the wheel. It's got to be tighter than that. And the way you tighten it on is there's a locking button on the back of the machine right here that you have to press in. So it won't go all the way in until you start spinning the wheel. And then once you get into a certain location, it will go in and lock the wheel. That way you can tighten on the disc. And now it's on there tight. You have to take it off the same way. You push in the locking button and go counterclockwise, lefty-loosey, right? Until the button goes all the way in, and then keep going and it'll loosen. So this is the locking button in the back. It locks the spindle of the tool from spinning. If it's not pushed in, the spindle will just spin. So the locking button locks the spindle. So putting the other tools on, you have to use the two locking nuts. One is the bottom and one is the top. The one at the top has holes in it. The holes are to get what's called a spanner wrench on it. The bottom one has a little groove in it. You have to make sure when you put the bottom on, it's put on correctly, because this is the bottom of the bottom locking nut. The opposite side has a space for the disc to sit onto. The center of the disc goes around that little hub. Okay? So it goes on like this, and that little groove is important on the bottom of it. That groove sets into the grooves on the spindle. The groove has two cuts on the sides of it so that the grooves in the nut fit over the spindle and lock into it. This goes over that way. And then you have to turn it until it locks into place. And when it locks into place, you'll know, because it will spin the spindle. The spindle will start spinning. So that has to be locked into place so that it gets a secure tightening of the tool. Now I can put either on the cutting disc, where it sits right over top of that hub now, or the grinding disc. Okay? If I put on the cutting disc, then the top part that goes in has to go in with the flat part down. Like that. So it's flat against flat. If I put the grinding disc in, which is what I'm going to use to clean up this mill scale on these parts, you can see there's a little depth still left over inside there. Now you put the hub on this side down into that gap there, so you have to put the flat side out on this side, and when you screw it in, it will go inside the cup of the grinding wheel, you can see there's like a little indent in the groove in the center of the wheel. It's dented in. That's to fit the locking nut. So now I put the locking nut on, and it's only hand tight now. And you can check the wheel to see if anything moves out of place. It should be snug and not move anywhere. Then you can tighten the rest of the way. And you do that with the spanner wrench. So you take the spanner wrench, and it goes in between the holes now, right? But you also have to lock the locking button in the back and rotate the disc until it locks. Then you can put the wrench on, and once you put a little bit of pressure on with the wrench, you can let go of the button in the back and pull it tight. Since it's an electrical machine, I'm going to check the cord before I plug it in and start using it. By the way, as you're changing these discs out and everything, it should never be plugged in. So I'm checking the cord, and this is a relatively new machine, but you never know what happens, who used it before you, where it was stored, what could have happened. So always check the cord. Okay, the cord looks good. So I'm go ahead and plug it in. Now I know it's off because you have to actually squeeze the button in for it to work. And I'm going to show you that right now. You might have noticed I've been wearing a safety shield because when you're doing, especially using the cutting blade, you should not only have safety glasses on, but also a face shield that will protect your face from all the flying debris. It will give you a much better protection than just safety glasses. So that's why I'm wearing a clear face shield over my safety glasses. And these discs, if they're in the cut, inside the cut of the metal, say like that deep, and something happens, it could shatter, and because it's so thin, and little pieces could go flying. You have to protect your face and eyes. Now, I can worry about the angle grind later. I can do it here too as well. I can do it with this machine, and I'll show you how, but I can also do it on the belt sander, the grinder, or something, the bench grinder. But since I'm taking off the mill scale on this right here, I'm just gonna cut the angle on it too while I'm here doing it. So I'm gonna clean up the side and get it ready for weld. First thing I need to do is clamp my work, because I do not want this moving on me when I start working. So a workbench, if you can get your material in a vise, everything should always be clamped rigid and stable before you start working on it with these types of machinery that have very high RPMs and a lot of forces going on. You don't want things flying in the wrong direction. So I want it stable and secure where it's nice and safe to work on. There. The clamp, I'm making sure the clamp is out of the way so I can work in my work area. And it's nice and secure. And it's hanging off the edge of the table a little bit in case I need to angle down or get down a little bit more down here, and I don't hit the table and ruin the table. All right, so now that I'm plugged in, the way you operate this machine is by this switch right here. You hold this handle and then hold this side of the grinder, and then you just squeeze this big black button. But there's a safety switch there too. You have to flip the safety switch, then pull the trigger. And I always give it a quick test to make sure nothing flies off or make sure it was hooked up correctly. So just pull the safety switch down and squeeze. Okay, it seems to be operating correctly. The handle's nice and tight. It didn't loosen up on me and start twisting because these just screw in and out. They just screw in and out because if you're left-handed, you could put it on the opposite side and hold it with your right hand and control the trigger with your left hand. So these are multifunctional, but make sure the handle is tight when you use the tool. And don't cross thread the handle when you put it in. If it doesn't screw in easily, if there's something wrong, don't keep screwing it in. So it's tight, it's ready to use. Okay, machine's functioning properly. Okay, so I'm just lightly gonna touch the stone across the surface of the material. If I push too hard, it's gonna dig in, and I don't want that. I don't want to ruin the material, so I'm just going to lightly touch it across the surface and keep moving while I'm doing it. I don't want to hold it in one place because it'll keep digging in. So I'm lightly going to push it across the material and remove this mill scale gently. It's a rough stone, so I don't want to dig too much of the material out. Then maybe I'll turn it and clean up the edge a little and then grind off the corner. So I'll show you how that looks now. now that the metal is ground away and the mill scale is cleaned off, if I really wanted to, and I would reserve this for later after the weld, because after you weld, you need to grind the weld and clean the weld too. But you can put the but if you were done at this situation and you had no more to do, you could take off the grinding wheel, put on the flap disc, and you can clean up the grind. And this is the finished cleanup. As you can see, this flap disc makes it nice and smooth and cleans up all the deep, hard cuts of the grinding stone. But I also ground over here or sanded over here with the sanding wheel, and you can see what the sanding wheel did. But you can see that it doesn't really cut off the mill scale, where the stone actually cuts the mill scale right off. So even though the sanding disc makes a nice, good, smooth surface, it doesn't really cut into the mill scale the way the grinding stone does. The edge is cut at 45. I ground the edge down. Here is the cutting disc, and I'm going to show you how it can cut through metal. I just want to touch on the fact that you'll see a lot of these people in industry without the safety guard on here. This safety guard is removable, and some people will take it off, and also the handle. So you will see people just using it like this without the safety guard. It's really not the safest thing. These are professional people that are used to using the tool an awful lot. My recommendation is do not ever do it, because your hand is much more valuable than the aggravation that it may take with the guard being there. Because if you slip and hit your hand into this tool, that's a cutting tool, it will take your fingers off. It cuts through steel, it will cut through skin and bone like it is nothing. Always be the safest you can be, because you never know what is going to happen. This is the cutting wheel on steel. I just want to tell you right now that this is not really the best way to be using this tool, because the rotation right now is this way, and it's wanting to kick the tool back at me. The vise is over on this side, right? So I can't get the machine there. But to show you the difference, I think I'm just going to turn this around and put it on this side. You're not going to be able to see as much. And this is why the tool is the guard is helpful too, because it's going to keep the sparks from flying at me. It's going to shoot them around the guard and down, or that way. The tool is worn, the disc, so I'm not going to use it anymore. There was a little chip in it when I started, so I didn't want to use it, but I did anyway. I'm not going to use it anymore because it's throwing little bits of disc at me. Okay, so I changed discs because the other one was getting worn and I was having a little trouble getting through the steel with it. Much better. That was a much better, easier cut with the new disc on it. But let me just say that you can cut, this is not the best use for that tool, cutting that piece of metal off. For when you can't use any other process, a saw would have been much easier to cut that off. Some kind of tube, sometimes you can't reach, you can't get into with a saw. You have to, it's things that you can't use any other process for. That's what the cutting wheel is good for. It's not good for all-purpose cutting. Don't ever think you can use that for all-purpose cutting. It's dangerous with the high-speed wheel going, and if it breaks, there could be a lot of problem. There's a lot of sparks flying. It could melt your clothes and burn your clothes. So there's a lot of problems with this. It's only as needed. If you only ever need this, you will use it. Otherwise, there's a lot of other cutting processes we can use to get a piece of metal cut.